Hello, and welcome to day 30 of our Cloud series. Today, we are going to, crown all of our success so far. And what we are going to look at is to work on the Smart Corporate Search application. So this is going to be an application that is going to help us to integrate a lot of the features that we have learned so far. We will look at integrating Terraform to build the infrastructure. We will look at building the various images. We will look at setting up Cloud Run, setting up Cloud SQL, and direct VPC egress for communication between the Cloud Run services and Cloud SQL. So we will try to, as much as possible, to put a lot of the concepts that we have learned so far into practice. Now, I will just, without wasting too much time, I'll just jump into the architecture. So if you look at what we are going to have, we are going to have a service where a user can query right from the front end. Now, I use Streamlit to build this, right? And then we will then send a query to Google ADK, right, which will have the AI agent that will orchestrate or answer our questions. Now, the AI agent will then have access to a toolbox, which is the MCP Toolbox. So, MCP Toolbox, we will talk about it. And then that will then communicate also, the ADK would also communicate with Google AI Gemini models. And then we are going to go ahead to execute some Postgres database, right? We are going to have a Postgres database as the backend. So, yeah. So that is going to be the whole architecture. We will talk about in sequence what happens. So when the user sends a request, is going to ask about something. Now, what we would do is because, we don't have access to some kind of live, data or an organization that we can just use, we will just put into the database some sales, customers, and then products as a demo to kind of test out being able to ask questions from the database using natural language. So you can ask the user can ask a question like, who is our biggest customer? You know, and then the front end will process that, query or send that query off to the retriever agent, right? So we have basically three services here. One of the front end, the two is the agent, which is D2, and the third one is the MCP toolbox, which then connects to the database. So you ask a question in natural language, the retriever agent tries to understand it and then generate some kind of a SQL plan, right? Then it it goes ahead to use, of course, Gemini AI is the one that we are using. It goes ahead to kind of come up with a SQL strategy, and then it executes the SQL tools, which then communicates with the database, right? And then returns some results. That result is then sent back to the retriever agent. The retriever agent then takes whatever information it kind of gets or the results it gets from the SQL operations that it runs, and then it sends it to the presenter agent. Then the presenter agent is the one responsible for generating insights from the data and visualizations, right? So the visualizations, we are going to be using Vega-Lite charts. And then those visualizations are sent back to the presenter agent, which then forwards that response with the charts, if any, to the front end. The front end then kind of displays that for the user. So we have this kind of a pipeline, and we are going to try to orchestrate that both with our code and then with Terraform. Right. So let us just take just a little bit of a peek into each of these services, right? So we are going to take a peek, look at each of these services. So now, if you consider the project, what I've done is I've also set up a Docker Compose YAML here. And so you are able to really also test out the project locally without necessarily having to deploy the application to production or to Cloud Run. So you are also able to test out the process locally. So let us try that. So Docker Compose app. You can try that as watch so that it will just watch for any changes that you make. Um, so we'll try that. I think I should have done that as build because I have made some changes. So it might not be reflected since I didn't do the dash build, but let's see. Let's see. Um, Yeah. So you have the various, applications running. So let's just test it out and let's see what the result looks like. So let's see, localhost 8501. So this is our Streamlit front end. Right. So whilst, we try to test it out, let us just try to review what we have. So on the front end, we just have a Streamlit application, right? And if you are not aware of Streamlit, I wasn't even aware of it until like 2 weeks ago, and I decided to go with it for this project because I just feel like it's just good for something like this, right? If because I like to normally build applications manually myself, right? And so I will have maybe my JS framework, like maybe Tanstack start, and then I would go ahead to kind of put things together in React and then build the application. But with Streamlit, it helps you to easily get started. And I feel like if you are working on a data science path or any kind of path where you need to quickly deliver dashboards and maybe quickly deliver, let's say, visualizations, flows and charts and stuff like that, it's just the best way to go. And it pairs so well with Cloud Run because it allows you to use basically a Python server, right? And then you can actually kind of write your Python code, kind of like if you look at maybe React Server functions, right? You are not necessarily going to write React Server functions, but then it implements something similar to that, right? Where it just makes some kind of I haven't tried to find out, but I'm thinking it's RPC. I haven't really, but it's the concept feels like RPC, right? Because you are executing some kind of so remote procedure call. So you are executing some kind of a function on the server without necessarily, let's say, importing that code to the client or without having an API endpoint. So you are able to execute some function on the server, right? So it allows you to do this. And so you can imagine a situation where you even have, various flows or various data, like with NumPy and stuff like that. You can just be able to visualize that data or the tables inside your application as quickly as possible. And you do not need to, kind of get to know a lot of things. You can write text, you can, do layouts, you can do charts, you can do even multiple pages if you wanted. Right. Of course, this is based on a single page application. So it's basically going to use JavaScript to kind of mount your whole site. Right. So it is a single page application, an SPA, and then it uses JavaScript to kind of perform the interactions. So just in case you are not aware of it, if you are looking for a quick tool to get you started with Python, building a web application, and also especially if you have interactive components that you want to kind of create or set up, and you want to integrate with maybe some kind of Python tools, and you don't want to kind of build another API endpoint or stuff like that, it's just very good to get started with. So you can see we set up some page config like the page title and even page icon, right? So as you can see here, you can see the page icon right here. And you can we set some title. So that is the title that you just see right here, right? So I don't really kind of like even build um, some kind of HTML or stuff like that. You have access to so many text elements that you can use, right? You can also actually use even HTML itself and write raw HTML if you wanted, but I'm just using the title and then the caption, right? And it also builds these hyperlinks automatically for you for the various headings, right? So if you had multiple headings, it automatically has that hyperlink built out for you. Right. And what we are doing is we are just because when you are working with Streamlit, right? If you want to basically, once you make some kind of a change, right, and then you want that change to be reflected, what Streamlit will do is it will rerun your application from the top to the bottom, right? And once it does that, you will lose some information, right? So if you don't have anything saved in some kind of a state or some kind of a persisted manner, then you will just lose it because it just reruns the application from top to bottom. So what it allows us to do is it allows us to have access to what we call a session, right? So immediately I visit my application, it creates a session for me, and then I can use that session to then store some information, which is then persisted when it re-renders or it's kind of reruns the application, right? So it persists the data in the session. So you are able to put information there at least till you refresh the page, Right. So each user has its own unique session, and you can put information into the session state, which can then be updated. So even when you have like inputs where you type some data into, you can put that input information into the session state, right? Or you can put a key on it, and then that will automatically be put into the session state. And then that means that when the application reruns, when maybe you have an on-change handler on the input or something like that, you will be able to keep the state of that particular input. So we just, initial messages. So you can see here we have the hello, right? So that is the initial message we pass. We go ahead to kind of go through all of the messages inside the state. If there is a chart, right, that means that maybe the AI has returned some kind of a chart. Then we use Vega-Lite to display that chart, right? And then else we go ahead to just display the text response in Markdown. So all of these automatically without I having to kind of install some JS package or something like that to render Markdown. It will automatically be able to, it understands and will automatically render Markdown in HTML for me. And then here, I just create, an input. So you can see how simple it is to just create an input, right? But they have different types of components. What we are using here is the chat component, right? So that is why you can see it will automatically render it this way and automatically render this here for the chat input, right? But in other cases, you have different inputs. You can, of course, render it differently. But this is like the chat input that it has. So that's what we are using, right? So you can see here we are starting, a chat message as the user. So once you type in the question is going to show up as a chat message. And then we go ahead to kind of start a chat message as an assistant. So like the AI is generating some kind of a response. And then we call our function to generate the response, and then we render the markdown of the response, right? If you look at the response generator, we go ahead to display some status, we check for errors. And there is a bunch of things that we do here. I don't want to really go into the details. You can always check the code. But then we, for instance, check if there's a function call, right? Because when we make that request to the API and then Google ADK kind of gets back the response, it will contain information about any function calls. So we just display a summary of those function calls, right? And then we go ahead to then write, okay, we have some database operation that we are being performed. We update the status that, okay, the analysis is completed. We look at the final response. If it has, a visual, then we go ahead to JSON load that visual, right? We perform some additional validations for that data. And then we go ahead. Basically, we just want to load whatever JSON, stringified JSON that is returned as a Vega-Lite chart, right? So we go ahead to do that, and then we go ahead to return this response, right? And if there is an error, then we also show that, oh, maybe there is an error in loading the charts. I experienced that a lot where the model was just not returning the Vega-Lite chart. I was thinking probably I have to maybe look at finding a Vega-Lite tool so that in that case we can be sure that whatever response is generated is accurate, because it was just sometimes hallucinating and getting a lot of errors in generating the chart. But you know, and if the response is unable to answer, then we just display some information about it. So this is just what we have on the front end, right? Now let us just quickly jump into the AI agent, right? Because as you can see here, um, when we are using Google ADK, right? So this is how we kind of communicate or generate an AI response. We get the environment variable, which is the agent URL, right? And then we go ahead to use ID token, right, from Google Cloud, right, to then fetch some kind of an ID token for that agent URL, right? So in production, what this basically means is that we want to make a request to the AI agent, right, from the front end, but we want to do it such that we add an authorization header, right? So you need to generate some kind of an ID token, but that ID token has to have an audience pointing to the URL that you want to make the request to, right? Or else it will fail. So that is why we use the agent URL. Then we fetch the ID token, then we put that into a bearer token header, and then we make the request to the API endpoint, right? Now, when you are making requests to Google ADK first expects you to set up a user and then a session ID, right? So that is how it can help you to track conversations. So some user can then create multiple sessions which represent different conversation threads, right? And then the backend can then maybe save those conversations to some kind of a persisted state. So in some situations, if you are using Google ADK with the what do we call it, with agent engine, with Google agent engine, then you can use the Google agent engine session memory, so that in that case it will be saved or persisted with Google agent engine. But in our situation, we are not using Google agent engine and we are using Google Cloud Run, and so we are just going to persist the conversation and then the chat to memory. So once the Cloud Run service is, destroyed, or maybe it scales to zero, we will lose that state. It is fine for us. It's just we are just doing it for demo, but in production you might want to look at, I think probably, let's just see. If you look at Google ADK and then you want to persist the state, so you can look at session and memory and then sessions. So you should probably be able to find, I think it's memory, right? So you should be able to find where you can store it. So you can see there is a Vertex AI memory bank, right? Yeah. Yeah, there is a Vertex AI memory bank that you can use. I'm not sure because I know you need an agent engine for that. I'm not sure if you can use it outside of agent engine, but I know you need agent engine. So you can use the Vertex AI memory bank, or you can use in memory, which is what we are going to be using, right? So once it is destroyed, it will just be gone, right? But in production, you might want something persistent like the Vertex AI memory bank, right? So yeah, let us continue. Yeah. So we make this with this request to basically get an authenticated bearer token that we can then make to the API. So we first ensure the user session. So we first go ahead to kind of create a user session, right? So as you can see here, we try to not make this request multiple times. So the first time that we make the request to create the user session, the user and then the session, we just store it inside the session state, right, of Streamlit, so that next time we don't need to make it again because we've already created that user session, right? And so you can see here we just have some session ID and then there's some user ID, and then we make some requests. Now you can pass in some state delta, which can then have some user information. So you can maybe pass in maybe like the user's preferred language or any other information about the user. We just want to make this simple, so we are just saying a type is anonymous. We don't really care much about the user's data. And then we create that session. So once we create that session, then we use that session to make another API request, right? To then go to the corporate agent, right? And then we pass in the user ID, the session ID, and then we pass in a new message, which then has the row and then the parts. Of course, if we wanted, we could have passed in the whole conversation history by passing in multiple of this, probably this object. I'm not exactly sure. Is not something I've looked at, but I probably it could be possible. I don't think so because this new message, it looks like it's not an array, but it's just an object. You can probably refer to the API server, right, which is what we are using, right? There are multiple ways to kind of communicate with the agent, but we are using the API server, right? So that we can use it on Cloud and then we can make API requests. But let's not worry about that. I think we will spend too much time if we focus on that. But that is the basics of the front end, right? Now, if we look at the AI agent, we are using Google ADK, right? I just didn't mention it much because I wanted us to kind of, when we get there, then I'll talk about Google ADK itself, right? So we are using Google ADK, and then because we want Google ADK to kind of act as an API, they provide us with some ways to kind of set up API. So what you can see here is just a way to set up the API, right? We enable Cloud Trace. So in production, we set this to true, but in development, we don't set that to true, set that to false, right? You can decide to serve a web interface. So this will serve some kind of a web interface from Google ADK that will allow you to test out the the agents, right? But we don't want that. And you can set up some allowed origin for calls. We are not doing that. We are making server requests. We are not exactly making requests from the browser because the request is going to happen on the server, right? As you can see, even though we are writing the code here in Streamlit in Python, it is not going to run inside the browser. It's going to run on the server. That's why we can access like request module and other server modules, right? So that's what I'm saying. I think it's probably some kind of RPC. So it's making some request to the server and then getting back the response. So we look at the main and yeah, so you just specify the agent directory, which is where are all of your agents, right? So it can be able to reach out to them. So as you can see, we have the corporate agent. So that is why in our Streamlit request, we specify here that we are going to the corporate agent, and then also here to specify that we are going to our corporate agent. That's the app. You can create multiple agents or multiple apps and then make requests to each one of them, right? So Google ADK is basically a way for us to orchestrate our agent, AI agent. So you can have multiple agents. You can be able to kind of have the agents delegate tasks to each other. You can use tools. Yeah, and there's so much more that you can do, right? If you visit the API documentation, I think it was much more recent, but initially it was the support was Python and then Java, but they have recently released support for Go, and I think even much more recent is the TypeScript one. So if you are into TypeScript or Go, Google ADK has released those ADKs, which is very good. Um, but if you are into Python and Java, those have been around for a while now. I think they started with Python and then Java and then Go and then there's the TypeScript one now, right? So there is so much more that you can do with it. You can integrate or let it talk to various MCP servers. um, you can set up some kind of observability. You can have evaluations where you kind of evaluate the results of the agent to make sure that it goes according to certain criteria. If not, then you can modify or tune the agent instructions to kind of update it, right? But you have so much more that you can do, even adding multiple agents using different workflow agents like a loop, agents that work in parallel, agents that work in sequential order. So we are just going to look at a few things that we did with the corporate agent. So if we look at our corporate agent, we have the corporate agent right here. So as you can see, let's see. So we have one agent called the retriever agent, as you saw in the diagram that we have here, right? We do have the retriever agent, right? And then we have the presenter agent. So the retriever agent is responsible, or is a data retriever agent that is capable of retrieving information from a corporate PostgreSQL database. It uses available tools to perform the query, right? So each agent, you give it some kind of a description, and then you give it some instruction, right? So this is the instruction to the agent on how it should work. So it should discover by using something like list tables to find out the tables. It should analyze the user's question. It has access to these tools that it can use, right? And then it should go ahead to execute the appropriate tools, right? It should use date ranges. If the question cannot be answered, right, from the available tools, it should give us a status of relevant, irrelevant, right? It should never assume the database structure. So these are just some instructions to the agent, and we have some generation config like temperature and output tokens and stuff like that. And we are having an output key here. The idea is that we want to tell this agent that once you kind of get the result from the tools or from the SQL queries, go ahead to store it in some state. So we have this as a variable. So you look at it, it's called SQL query data, right? So we have this as a variable because we want to pass off the information to another agent. So we just store this information inside an output key, right? And then we just send that information only to the other agent. So this is what is going to also be stored inside the session of the Google ADK, right? So this is going to be stored basically inside the session of the Google ADK, right? As you can see here, we provided some session URI as some, SQLite session that you can have. But it's going to store this inside a session, and then we can reuse that session. And it has access to to the tools from the MCP toolbox, right? So if you check here, we have the get SQL toolset, which then basically gets us the toolbox client. So the toolbox client just does some environment variable checks, and then it goes ahead to use the toolbox sync client, right? And then we provide it with our toolbox URI. So that's why I said we have three applications. So the toolbox service URL is also another application, right? So it then kind of uses this to then load the tools from the toolbox application. But as usual, that toolbox application will also be internal, so it will also require IAM authentication. So in the same way, we try to use this auth methods to get some ID token, and then we pass that as an authorization header to the toolbox client so that it will be able to kind of connect to it with IAM authentication. So in that case, we protect both our agent and then also we protect the toolbox, right? I will just briefly look at the toolbox. So just so we can kind of understand what is happening here. So if you look at the MCP toolbox service right here, right? What you have is just this, right? It's just a single Docker file. I could have just used this image directly. That is all. We don't need to update it. So the MCP toolbox is a tool that you can use to be able to connect to databases. And it kind of gives you an MCP server that is for databases, right? You have different SDKs like Python, JavaScript, Go that you can use, right? And the idea is that you will provide the service or the toolbox, Docker container or the service with some credentials to access some database, and then you can provide it with some tools. Also, by default, it does come with some kind of tools for the various databases that it supports. So if you maybe even check out, uh, let's just say I want something more general, right? If you check out maybe MySQL, right, it has some default tools that it provides you, which you can then use, right? So for instance, it gives you an execute SQL tool, which you can then use to execute SQL queries. It allows you to list the tables. It allows you to list tables missing unique indexes, list active queries, get a query plan. The Postgres one I think is much more extensive because it supports more tools, but then, it allows you to do these things. So what it does is it provides you a way to connect to your databases as and use those databases as MCP servers, right? And then kind of perform operations on them. So you can either use some of the defaults. So let's look at the Postgres one like this. I've not looked at the Firestore one. I really haven't. So okay, Firestore supports it supports add document, delete document, get rules, list collections. Okay, quite a few operations. Okay, so that is also available. And it supports Cloud SQL, which, you know, if you wanted to maybe list the Cloud SQL instances, create an instance, create a database, create a user. So it has all of these operations that are possible for some supported database services, right? So you can look at the various database services and then look at what it supports and integrate it with yours. So if you have a SQL server, it also supports that. Now, if you want to get started, right, you can go ahead to look at the SDK, right, and then look at the example that you have here. Now, what you have here is basically if you want to kind of use the MCP server, you need to provide this, right? You need to just use that Docker image, and then you need to pass in some arguments, right, to that Docker image. So what we are doing here this. So you need to pass in the tools file. So the tools file is what you kind of where you would declare both the source of the database and then also some tools that the AI agent should be able to access or the MCP server should expose. And then you can provide some address, right? You provide a port, and you can also provide some allowed origins. I think I've not done this yet for the production application, but then the idea with the allowed origins is that once you have the MCP server, any origin can execute it, right? But you can restrict it to make sure that only certain origins can execute it. So it's kind of prevents some kind of DNS attack, right? So you make sure that only certain, hosts can execute it. I partly did not look at this for the production one because we are already requiring IAM authentication. So without IAM authentication, the user cannot even call the service in the first place. But of course, in production, you should really look at um, adding the allowed origins, right? Yeah, yeah. I know we said we are deploying this for production, but I think I just forgot to do it. Maybe we'll see if we can do it. So you provide this. So now let's look at the tools. Now I have two files for the tools, as you can see here, right? And if you look at the Docker Compose, you need to provide to it where the tools file is, right? So in development, we just go ahead to create or to mount the tools.dev inside app slash, tools.yaml, and then we provide it as a command to the container. In production, right, we will just use the tools.yaml file. But I did it differently because here I want us to use the Postgres server in Docker Compose, so that is why I have it here. But then in production, we are rather connecting to Cloud SQL, right? I also didn't want to connect locally to Cloud SQL, right? So it's only in production that we connect to Cloud SQL. So you can see here we provide the source, which has the database information. So in our tools.yaml, you can see that is the database information. So you have a project, you provide your Cloud SQL database name, the database itself, the name of it, the user of the database, and then you provide some password, and then you say there is the IP type private or public, right? And for us, we are going to be using a service account or an IAM account. Google Cloud SQL supports you using actually an IAM account to authenticate with your database. And so that is what we are going to take an advantage of. So in that case, we will not need an actual user and then password. So we will just use the service account that is attached to the cloud and service as a way to authenticate to the database, right? Because the Cloud SQL supports that. So you provide a database user. In those cases, you don't need to provide a password. Your password can be empty, but you just need to make sure that in Cloud SQL, you go ahead to connect to it and then you allow your database to talk to you grant that user. So after you add the user to Cloud SQL, which is the IAM service account, you need to grant that user permissions to access the database. So once you grant that user permissions to access the database, then that's it. You can use that connection or that user to connect to your database, the service account in this case. And then you provide some list of tools. So these are the tools that it should have access to. So by default, you provide the kind of the tool. So as you can see here, if we look here, let's look at the Postgres one. Let's look at the Postgres one. Postgres, where is it? Where is Postgres? Okay, yeah. Yeah. If you look at the Postgres one, there are so many, tools that it provides. So it provides so those tools that it provides here are the kinds, right? Those are the kinds, not the tool names. The tool names you can give it any name, but those are the kind that we use, right? And then you tell it what is the source. So our source is this, the Postgres source, right? And then we have some description for the AI agent to be able to understand what this tool can do, right? And so we kind of say, okay, so the kind here is PostgreSQL. So if you look at it, we do have the PostgreSQL kind right here. PostgreSQL, we have it here. So this then allows you, what the tool is, allows you to execute predefined SQL statements against a Postgres database. So that is what we are using here. So as you can see here, we do have a tool like get sales KPIs, which we give a description and then we say the kind is PostgreSQL, right? And then it should accept some parameters, start date, and then we provide some description and then end date. And then we go ahead to provide the statement that it should perform. So we are selecting the total amount, quantity, and then we are doing some sum here to get the total profit, right? We select it from the sales, we join it to the products table, and then we perform some other operations here. So you can see that we are doing this for a couple of the tools, right? So this is how you provide the tools for your MCP server. So this is how we are basically providing the various tools for the MCP server. And then finally, you can have multiple tools and then you can put those tools into two sets, right? Or you can load all of them. But what I've done is I've just put it into two sets. So we have an e-commerce two set. So if you look at the main.py here, sorry, not the main.py, if we look at the agent, the pie, you can see that when we load the two sets, I'm loading the e-commerce two set. So this is then going to give us this two set. And then we are going to access it, and the AI agent is now going to be able to access these tools. So we now have an MCP server that the AI agent can access, right? And then it will go ahead to execute the query. So once it's done, it would then pass it off to the next agent, which is the presenter agent, right? So that one specializes in kind of displaying the final results in a friendly format. So you can see here we are trying to access the state, which is why we put it here into the output key. And then we try to access that state information right here. Right. So once we access that information, we tell it, okay, so this is the information, go ahead to kind of review. If the status is irrelevant, that means you are unable to answer, then you can provide a specific reason. Maybe the question the person is asking is not really available, right, in the database. And then if it requires some kind of a trend or some kind of a chart, we tell it to basically use Vega-Lite spec, right, and then generate some kind of a chart. If it requires text summary, then it should go ahead to just analyze and then give us reasons behind why, right? And then it goes ahead to, we also tell it that for monthly revenue questions, you go ahead to kind of generate a Vega-Lite spec, right? And then we give it some kind of an example, right? Whereby we have the Vega-Lite spec to help it, because the Vega-Lite spec, it was just hallucinating and having so many issues with it. So you can see there's a lot more of the instructions around the Vega-Lite spec alone, right? So I'm hoping next time maybe I'd rather get a tool and then use that tool to do it. But for now, it's just so much. We had to do so much just to make sure that it works. And then finally, we are kind of putting the result into some schema, right? So it has to send a response type, which we then kind of process on the front end differently based on the type. And then this can be optional. So Vega-Lite spec can be optional because it can just answer simple questions without requiring that. So as you can see here, when you are building Google Agent ADK, for any agent at all, you need to provide the root agent. So our root agent is going to be a sequential agent. So we are telling it that is going to kind of run it in sequence. So first it's going to do the retriever, and then after that it's going to run the presenter, and then after that it's going to return the results. So we are having a sequential agent here, right? I was trying different ones like a loop agent, but sequential agent works best here for us because we want one agent to execute, and then after that we want the next one to execute. So it's just a matter of like providing some sequential agent and then providing some kind of sub agent. So you can see the name is still the same, so corporate agent, so that we can access it from the front end. So this is basically, I know we've spent a lot of time. Probably, I think if you are interested rather in infrastructure, you can probably skip this part. But this is basically the analysis into the application, right, itself and the various components that make up the application. So we have looked at the application itself. Now, let us look at the infrastructure behind it, or let us just test it to see. So let us type some question. So let's say, who is the customer that, like, just writing some question I'm trying to formulate that gives us the highest revenue, right? So who is the customer that gives us the highest revenue? I'm just trying to find that out. So I ask this question, and then it's going to go ahead to run that query. So it's going to go ahead to use the tool. So as you can see here, the status, we're able to see some of the database operations, right? So you can see here that it made a query to get top customers, and then it added a limit of 1, and it was able to now present the results and then display it for us. So if we can try a query to kind of generate a chart. So let's just say maybe let's just say I want something that would generate a query that would generate a chart. Mind you, the SQL data that we kind of inserted. So you can see here that when you start the Docker container, we do run for the Postgres server, we do run some init SQL. So this then goes ahead to kind of um, generate some default data for us and create some tables, right? So we have the product, customers, and sales, and then we kind of insert some demo information. But mind you, the dates are all 2024. So if I wanted to ask a proper question and get an answer, I need to use 2024. So we can say, let's see. What is the question? What is the question? Let's say, what is our revenue per month in 2024? So this should be a question that tells the agent to generate a chart for us, right? Because it's kind of like it needs to display some kind of analysis or time series, right, um, across some kind of a time. So we need to be able to get some kind of a time series, like each month, what does it look like, right? So you can see here that we do get the Vega-Lite chart from it. This Vega-Lite chart makes me a bit frightened because it's just so many errors that I was just getting because the response from the AI was sometimes inaccurate. So let's hope that in production we don't also get an error. But okay, in development this works all right, right? It says every developer. Okay, so the monthly revenue for 2024. So you can see that, and then we have the various months and then the chart displayed, and we have an answer, right? Which explains the chart, telling us that we reached this peak, with May recording the highest sales, followed by October. So it just gives us a few information about it. So this can be something very useful that you build around your database, and then it kind of like can give useful information to people who want, answers about, how maybe something is working or internal systems about sales and stuff like that. Like even if you are working in hotels, you can think of something like maybe how many people or what is the day that we have more people visiting the hotel. You can be able to answer those questions. So we have this information. And because we are using a Streamlit with Vega chart, we do get some additional options. You can save the chart even as PNG, as SVG. You can view the data behind the chart. Right. So you get some further options. You can, even move this around. I realized it later on. You can even do some further filtering. Right. All of these without, if I was to do this in JavaScript, I would have had to write a lot of lines of code. But then Streamlit provides all of these tools kind of like automatically available, and you can do all sorts of things with it. Right. So it's very good if you have data visualization and other stuff like that you want to just use. I feel like you should go for it. Yeah, so we have that. And it doesn't only support, Vega-Lite. You can check the chart section, and there are other options that you can use. You can just provide area charts where you just provide some kind of data. So some from NumPy, using NumPy, or you create some kind of a data frame, and then you can just let it provide some chart for you based on the data frame. So it's not that as if you have to use Vega-Lite charts or something like that. Yeah. So that is the part of our application, right? Now, let us move on to look at the infrastructure, right? So let's look at what is the infrastructure behind this, right? So I would explain the infrastructure, but then whilst I'm explaining, I would also go ahead to run it because it will just take some time because we are going to build Cloud SQL and other stuff. So what we have here in Terraform is we have modules, and then we have our foundation, and then we also have our runtime, right? So the foundation is going to build some resources that is needed for the whole setup. This includes our artifact registry, our Cloud SQL, our VPC. So those base setups are going to be inside the foundation. So we are going to run the foundation first. Then after that, we are going to build the image, right? The Docker image, and we are going to put it inside the artifact registry before we go ahead to also run the runtime, which now contains the Cloud Run services, right? So the service account and everything is inside the foundation. So we'll go through just a little bit, but I just want to run it now because it takes some time. It has to build right. It has to build the various services like the Docker, the Cloud SQL, and then it also has to create a connection from Cloud SQL to the VPC. So it just is going to take some time. So let's just run it. Let's just first do Terraform init to make sure that we are in the right place. And then let us go ahead to do Terraform apply. I know we should do a plan first ideally, but let's just go ahead to apply. And let's just close all. Right. So we will go through the resources, but as you can see here, we have a couple of resources, over 35 of them. It includes VPCs, it includes service accounts, IAM role bindings for those service accounts. It includes secrets, right? And it also includes the Cloud SQL server itself, right? We are provisioning a very small Cloud SQL server for testing purpose. We will go through the various sections, but let's just kick this off. I'm hoping that there will be no errors. Fingers crossed, because let's see. Let's see. Fingers crossed there are no errors. Okay, so let's go ahead to kind of look at what we have, right? I really am a bit scared of this thing erroring out. So I'll just open a new browser tab. I don't want to look at it. I don't want to look at it. I'll just kind of look at it once I see this Terraform is gone. That means the command execution is done. Let's just continue. So what we are doing with our infrastructure is we are using various modules. The idea behind modules is you kind of want to group codes much more efficiently so that you can reuse it in multiple places. Right. I started with modules before I thought of kind of separating the infrastructure into foundation and then runtime, because I thought modules would be easy for me. Right. But after I separated out into foundation and runtime, I could have kind of come back to simple, like maybe vpc.tf file to contain all VPC resources, and maybe artifact registry.tf file to contain all artifact registry resources. But I had already started with modules, so it was like, okay, let's go ahead with it, right? So the reason I also separated out into foundation and runtime is that I realized that some of the resources depended on others. Like, for instance, I needed an artifact registry to be around, and then I needed to build an image because Cloud Run on Terraform does not support you actually building the image itself. What you can do probably is to create a cloud build trigger, but it does not support you building an image. So if you are creating a cloud run service in Terraform, you need to provide the image URL. And so without the image URL, then we are basically not able to deploy. So instead, I decided to build the foundation. Then after the foundation, we go ahead to manually build the image, right? And then we will then build the cloud run services, right? So you can see that highlighted a bit when you come to the the deployment. I think if we look at this, if we come to the deployment section, we should be able to see that. Let's see. Oh, okay. Let's see. I think, yeah. So step one, you deploy the foundation, right? Of course, you need to update the Terraform auto.tf vars, right? Which should have your project ID, with your project ID, your region, and then your zone, right? And then you should also, if you want to change these names, so if you want to change your Cloud SQL instance, the Cloud SQL database, and then also the artifact registry, then you should go ahead to also update those variables in your Terraform. Where is that? In your terraform.auto.tf vars, right? You can change that. So once you are done, you go ahead to plan and then apply the infrastructure. So this is going to create these resources, right? But you need to go ahead to build the container image and then push it to that registry, right? So you build a container image and then you push it to that registry. And then you go ahead to also create the secret versions. I did not want us to put the secret versions inside the Terraform because then it might then be in state, right? So the actual secret value might then be in state, which we don't want. So we create the secret versions outside of Terraform, but then we create the secret itself inside Terraform, right? The two secret that we create is like the Gemini or the Google API key, and then also we also create the where is it? We also create the MCP tools config, right? That is the tools.yaml for the MCP server, right? A very good thing I forgot to mention is inside the inside the AI agent, we actually use different AI models, right? So we use Gemini 2.5 Pro for the first model because I think that one needs to be able to communicate with, to kind of execute the SQL. Probably I shouldn't have used 2.5 Pro. On second thought, it should probably be maybe the presenter that I use Pro, which can maybe reason better and give us a better result. But initially it was because I was using the first model to basically generate a SQL query, which I wanted to then pass to the MCP server to execute. But then I realized that could, lead to security issues because you can also be very sure whether the model is going to generate a good SQL query. So that is why I rather created the tools and then I asked the model to query it. But it's fine. Right, I was looking for something in that manner. So I think probably this you can just still use Flash. But then the idea is that for each agent, you can use different models that are kind of more specialized for that particular operation, right? I think Flash can still do well here because it is just about, analyzing the user's question and then going ahead to use the tools to generate the result. So Flash can also do that, right? Initially, it was because I was also trying to generate a SQL query. So that is why I was using 2.5 Pro. But I think Flash can do that. Maybe I should be switching out this and then rather the presenter should be Pro so that it can give us much more better, let's say, thinking through the results that it presents. But you can probably use Flash for both and it will work out. I just wanted to mention that. Right. Now I am missing. I'm lost. Okay, yeah. So we create that before finally we go ahead to deploy the runtime, as you can see. So let us focus on the foundation. So we have various modules that we are using. So we have enable APIs module. If you look at the modules folder, we have APIs. So that has the main.tf, and then we have some variables that we can pass into it. So it's just to allow us to enable some APIs. That's all, right? So we are enabling some for APIs that will be dependent upon, which is login, monitoring, cloud trace, SQL, service networking, compute. This is for the IP addresses that we'll be using. So compute, artifact registry, secret. I think I've done cloud trace twice. Okay, that's fine. Uh, yeah, yeah. Let's just leave it for now. I just don't want to break Terraform and then, you know, I had issues with this. Let's leave it for now. So maybe in the final code, once I'm done with everything, I'll just make sure to remove it. Okay, and then we have the VPC networks. So we are provisioning the VPC network, which is also a module. If you check the VPC module, you should be able to see further information about it. So we have subnet. So if you provide any subnet, a variable for subnet, then it will go ahead to provision it for you. We just make sure we are not auto creating set subnets, right? And so we provide some subnets. So what we have is just the main subnet, and then we give it some CIDR. So you can check inside the variables.tf, you can see the default side. I don't think we are specifying another one. So we are just using this side, just something simple. 256 IPs. We only have 3 applications, so it's fine. We are not scaling to like huge levels, so it's fine because all of those applications we are going to connect them to the same CIDR or to the same VPC subnet. So we have that, and then we want to basically connect our Cloud SQL server to the VPC. So to do that, we are using private services access, right, on Google Cloud. And so to use private services access, you first need to create some internal address, right? So we do that here. The prefix length should be 16. And then we go ahead to then create a private VPC connection, right, which will be between our VPC, right, so the VPC that we created and then the new private address that we created, right? So this allows us to create a private service connection, right? So this, because of this, the Cloud SQL should then be able to connect to the subnet, right? Which we will show in a bit once we look at the Cloud SQL, and then it can be able to perform the actions. And then we then go ahead to pass in some rows and we create the service account, right? So you can see if we were doing this from the console, we have to click on a lot of things, right? You have to click on some buttons to create this address, some buttons to create that, some buttons to create the subnet, but we get to do all of these from Terraform directly here, right? And then once we are done, we can get to destroy everything, right? One thing to note about the private VPC connection is sometimes, it can leave some of the resources around. So what I realize is there are situations where I can destroy the private VPC connection, but then I can basically like destroy my Terraform, and then the Cloud SQL will be deleted and all of everything will be deleted, but somehow the private VPC connection will be having an issue being destroyed. So that is why I just set the delete policy to abandon, which it is also advised, or is not really advised, but it just prevent Terraform apply failures with Cloud SQL, right? It's just that the private VPC connection can sometimes lay around even after you have deleted the Cloud SQL service. You would be trying to destroy, and then you'll be getting errors that there is a connection to this particular, the VPC connection is having something connected to it, but you've already deleted the Cloud SQL. So it stays around for a few hours before it finally like is gone. So this is just to prevent that and just abandon that resource. And we also create the service account for the AI agents and then also the MCP Toolbox. We create an artifact registry. So all of these are controlled with variables which you can change. When it comes to the Cloud SQL, this is where provide some instance name. We are using Postgres 17. We are using a very small one. We just want to test some 3 tables or so. So there's no need to go big, and we are saying the delete protection is false. Of course, maybe in production, you might want to set this to true to make sure you don't mistakenly delete, but this is fine. I just didn't want to have to change this back to false when I'm trying to destroy, because that is what happens. When you set it to true, then that means when you are destroying, you need to first change it to false and apply before you now destroy. But I just wanted this to be a quick test. So that is why I've set it to false. But in production, you should, of course, change this to true, right? To make sure you don't mistakenly delete it. And then we specify some databases, right? Then we specify some IAM users, and then we specify what it depends upon. So this is how modules can make it easy for you. So all of the actual implementation code for the databases, the SQL, and then the IAM users are inside the modules. And I just need to use the module and provide some variables. So if I come to a Cloud SQL module, you can see the variables that dictates, or the variables that I have passed, right, are right here. So the instance name, the database versions, we have some validations for them, the database tier, and stuff like that. And when you come to the main, you should now see that this is where we now perform the actual operations, right? Because we want to allow IAM authentication with a service account, so we enable this database flag, right? And then, all of the other things that you pass, the IP configurations would then be passed directly here. This size by default, we are using, I think, 10 gig. So that is fine. This type is, I think, by default, we are using PDSSD or something like that. So if we check the variables and then we go to the disk parts, you can see we are using 10 gig by default. So that is fine. And then we are using PDSSD. So that is why here I'm not also specifying it. We are just using the defaults. And then when you come down here, you also see here that if you provide any variable for databases, then we go ahead to create the databases. So that is why we have here. So we have only the main database with the name. So we now refer to it here as the each.value.name. So we then create the database, right? And then we go ahead to now create IAM users, right? So if there is an IAM user, then we add a role binding with the role instance user, because whatever IAM service account that needs to access the database, it needs these roles. So it needs the instance user and then the Cloud SQL client IAM roles. So as you can see here, we pass in the service account for the MCP server, because that is what needs to connect to the database, right? So we pass in that service account, and then we go ahead to also pass in this role, right? The Cloud SQL client and then instance user allows it to be able to become an instance user and to also be able to connect to the database, right? And then we go ahead to say, okay, if you provide, because For the IAM users for a database, you have two methods. You have either you use a user account or you use a service account. If you use a service account, then you need to make sure you can use the whole service account email except this. So you need to remove this. So that is why you see some Terraform functions here to just make sure that we replace the service account if it is there with space. And then also we replace this with space to say, okay, nothing, like just remove it. Right, and then you specify the type. So here is a service account. If it is a normal IAM user, that means it is starting with user. Then we create a Cloud IAM user type. So we are creating a Google SQL user, right? And here, that is what we are using. But we are going to be using service account. So as you can see here, IAM users, it starts with service account. So this is what will basically run because this is what passes the for each statement the service account is to and not the user. So that is what is passing. So that is what will be used, and we will use the Cloud IAM service account. So we have this way to help us to easily provision our infrastructure, right? And then we create a secret. So we create the Google API key secret, and then we grant access to the AI agent because the AI agent service account is what needs it. And then we also create the MCP tools config secret, and then we also grant access to the MCP Toolbox service account, right? So these are the foundation resources, right? And we are controlling them with modules. So the modules make it easy. You can look at the secrets module, similar thing. It's just going to create the Google secret manager, right? And then it's going to add a member for all of what we do here. So the access members is going to make them IAM members by giving them secret accessor role on that secret. So we don't give or grant this role globally on the whole project. We only grant it to specific service account that we want to access it, right? And so we have that. Now let's look at our Terraform. Hopefully there is no issue. Good, 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 good. I'm so happy. Yeah, I'm so happy. So let's now look at the various resources. So we can refresh the various, I think, yeah, the various places that I've opened, the various consoles, and then let's see. Let us see. So IAM and authentication, this is where you will now see the service accounts, right? So we've provisioned the various service accounts as you can see here. So corporate agent, AI, and the AI agent service account, it only has these three rows. This one also has these three rows. And then this one also has the Cloud SQL client and then the instance user row, right? So I'm not sure. Let's see something. Let's see. Um, let's see. Okay. Yeah. Okay. So we do have those rows granted. Yep. So we do have those rows granted, and then we can come to Cloud SQL and then we can look at the instance. So we do have our corporate search DB instance also created. VPC, we have our VPC provisioned. And if we scroll just a bit, so we will see that we have a subnet provisioned here. So we have a single subnet. And if we scroll just a bit to the right here, we should see private services access. And we should now see that we have a private services access connection, right? So this is the connection, and you should see that there will be a VPC peering for that. So there is a VPC peering for that, right? So these are where, sometimes when you are destroying, you might have issues, right? And there was also an issue whereby the Cloud SQL, the I think the database was either the database or the users were destroyed first. So that is why I added some depends upon right here to say that the users depend upon the SQL instance and the database. So that means the database should be destroyed first before the instances, the user should be destroyed before the database and then stuff like that. But because I was having errors with that destroy. But if it kind of happens that way and you get an error, then I just have some local provisioner that will just echo something to you that, it may fail if IAM users still own database objects. So make sure to drop those database objects before retrying, right? Let's say hopefully it doesn't happen when I run the destroy, but should it happen, it's just as a note that you can take as something that you can take note of. So we do have that VPC access connection set up with PSA. We don't have any cloud resources, of course, but if we look at our database, we go to connections, we should see that now we have an internal IP address, and then we do have the connection to the network, right? So this is very good, right? We have this setup and this works. So you look at networking, you should be able to see there's private IP assignment to the corporate search, and then we are using private services access connection. We would have had to click on a couple of buttons if we're doing it from here, but through Terraform, we are able to kind of set this up in the right order. So if we come to users, we should then be able to see our user here. So you see it's the same email as the service account, just that we don't have the .gen service account at the end, right? And then you can also use groups if you wanted to kind of use groups to authenticate. And then you can look at the databases. We have the corporate data database, right? So let's look at our next step. Let's just visit the README just quickly. I think I didn't add this. Oh, I think I need to add it. Yeah. So we need to create our database users, right? So we need to create the database. Sorry, we've created a database user with the service account, but we need to grant it access to our table, and we need to seed our table with some information, right? So let us first do what we have in the README here, and I'll make sure that we add another one. Create secrets. Step 4, deploy the runtime. So we might need another one right here that says step 5 is to let's just say step 4, no, step 4 is to um, grant SQL user database access and seed database. So you need to also do this before you go ahead to step 5 to deploy the runtime, right? So you need to go ahead to do that step 4. So I'll go ahead to update this. I think right after I just need to remember it before I forget or something like that. Right after. Yeah. Okay. So we do have that. And so we need to grant this database access. So let us focus first on trying to build the image. Now, if you are using a Linux terminal, then you can just go ahead to copy export, but I'm using PowerShell, so it just works a bit differently. So I would need to use this instead, right? So this is how I set environment variables. So you set environment variables in PowerShell. So let's go to a new tab, and then we will replace your project ID with our project ID, right? Let me see something. Yeah, yeah. We replace your project ID with our project ID. So let's go ahead and then we'll say omni deploy dash run. Right, so this is going to set the environment variable. And then we need to go ahead to build the various images because this is the registry, right? Remember, we created the artifact registry. So we go to, I think I did not open that tab, artifact registry. We should see that registry created. So we go ahead to build the AI agent, right? So we do this, but remember I'm using PowerShell, so I need to do env history registry, right? And so we'll go ahead to deploy the AI agent, right? So we'll go ahead to build the AI agent and put it into the artifact registry, right? So this is why initially I couldn't really combine other Terraform resources because some of them needed to be done manually, right? I'm not able to build the image inside Terraform, so I needed to do that manually or separately. So you come here and now you should see that the registry is created, right? So the registry is right here. It was built in the foundation. So we have that registry. And so we are using that command, right, to then build the Terraform resources, right? Whilst that is building, we can probably go ahead to try, let's set it again, and then let us go ahead to just do the front end also because we can do that simultaneously. They don't really depend on each other, right? So we will do again, env is to, right? They don't depend on each other, so we can be building them at the same time, and there should be no issue. And then we will also try to build. So we are building all three at the same time, so that we don't waste time just waiting for um, each one to complete. EMV is to, oh no, mistake. EMV is to, right? And then we go ahead to build the MCP Toolbox too. So we are building all three at the same time. They should be built. I think my laptop is probably gonna slow down as a result of doing all three at the same time. But let's wait for that. It should still complete. Um, let's see. Yeah, so I think the MCP toolbox probably has completed first because that one is we could have just used this image even directly. But I was thinking maybe should we want to change this for some reason or add some argument directly inside the Docker file, it's best to have it here. But we could have just used this image directly. Yeah, so that one is just pulling that image and that's all. The rest are having to install Python packages and stuff like that. So they are taking a bit more time. So yeah, so that is done. So we have that done. So I will just close that. I think there is some error. Okay. Okay. Probably because I was running, those three builds at the same time. Ooh. So there can be something like that. I never knew. Okay. Okay. I never knew there can be something like that. I don't know what to do now. So what is gonna happen? Is it like just gonna freeze? Okay. Okay, let me not try to build all at the same time then. Let us try to so the MCP toolbox worked, right? So we would try to do the front end and AI agent again, just and this time we'll just wait for it to complete because yeah, it looks like there was some issue. Um, yeah. So we should be building one at a time, probably because I don't have my own build pool and it's using the default build pool from Google Cloud. So there's probably some level of restrictions to kind of maintain a quota for everyone. So let us so once that is building, so the front end after that we need to build the AI agent. Let us add our secrets, right? So we need to add the MCP toolbox. So we go ahead to copy this, right? And then we paste this. I think I want to open a new terminal. Let me just close because I think my laptop is slowing down. Let me just close the local service that we have because I don't think we need it. Docker compose down. Yeah, we don't need it for us. So we go ahead to add a new secret version because the secret has been created, right? So we point the data file to the MCP dash toolbox slash tools.yaml, right? So you point that as data file so that we have now that data created. And then let's see. Yeah, so we have that data created. Let's see here. So this has been created, success. So front end is created. So let's do for the AI agent. Okay, yeah. So let us do for the AI agent. Yeah, yeah. So we have created a secret version, right? So if we go to secret manager, let us also refresh this to see. Okay, so I think in some ways maybe the build logs or something like that failed, but it looked like the process still continued anyways. But let's just rebuild it anyways, right? Let's just wait for this to also build just in case, the AI agent had some issue. So you can see here that we have the secret created. So we have the Google API key and then we have the MCP tools, right? And the MCP tools, we have now created a new version for it. So that should then have the value. And then we will focus on the Google API key. So the Google API key, you can just use this to basically echo your Google API key, right? And then we just pipe it into the Google Cloud Secrets command to use that value, right? Of course, you need to make sure that after you are done, you kind of delete the file, right? If you are using PowerShell like I'm using, then you need to rather run this command first, right? And then you do this will then create a file with the value, and then you go ahead to use this to then kind of like save your API key, and then you go ahead to just delete the file once you're done. So I did it, and so you can see I have that secret file here. So I'm just going to go ahead to create that. So to add the secret version, right? Because I already have the secret inside the file. So I'll just go ahead to create the secret version. So we have the Google API key secret version also created. And we have also created our build our images. So we have done the secret, we have done the images. Now it's left with granting the SQL user database access and then also seeding the database with some information, right? So we will go ahead for this use case and for this purpose, we will just go ahead to create a test user, right? So I will just do some list here so that I can easily remember. So create test user, right? And then use Cloud Studio to perform a query to seed database and grant access to the um IAM user, right? So that is what we are going to do. So for this, because I just wanted to use Cloud Studio, I don't have a PG SQL connector locally that I can just use, right? And then I have to also allow or maybe use some kind of Google Cloud Proxy locally to allow me to connect to the standard database. It's a bit of a long process, so I just want to use Cloud Studio to make it simple. So I'll just add a new user account just for this test. We will delete it afterwards. So we'll just call it sample and then we'll just generate some password. Let's just make sure to copy that, right? And then we'll go ahead to add that user. So this is just for us to kind of just test out. So we'll come to Cloud SQL Studio. Then we will go ahead to select the database, which is our corporate data. We use the built-in IAM authentication. So we pass in sample and then pass in our password and then we authenticate. So Cloud SQL Studio allows you to kind of connect to your database and then execute any kind of queries that you want, right? And you can save these queries so next time you can come back and then reuse it. You have Gemini right here integrated that you can then use to even ask it questions or to help you generate the SQL queries if you wanted, right? So what we are going to do is we are going to go to our init SQL, right? And then we are going to first try to get all of the users, right, from our Postgres database, from our Postgres server, sorry, not our database. We are going to try to get all users, right? And this should now list all users. So we should see the sample and we should also see this IAM user, right, which we are going to use. So we should then copy all of the init SQL, right? We should then paste all of that here, and then we are going to enable the last statement. So the last statements are going to grant access, right, to the SQL account. They are going to grant access to the user, right? So we are going to copy this user name that we have right here, and we are going to replace the MCP user with it, right? And we're going to replace this, we're going to replace this, and we're going to replace this with that. So we are going to use, instead, we're going to use, yeah, quotes. Oh, why does it doesn't have a double quote at the end? Let's see, what is the error? Um, okay, mistake, yeah. Yeah, this should rather, oh, okay, this should rather be at the end, and then this should rather be at the end. Okay, why did I add grant? Oh, what's going on? Oh, what is going on? What kind of mistake did I do? Look at where my equal signs are. I sent it all the way to where 2 was. Okay. So this helps me because I was able to kind of the SQL editor provides us with some validation, so we're able to use that. So we just grant usage on the public schema to the user, and then we grant all privileges on the various tables that we have. So we grant all privileges on the sales, products, and then the customers table. That is all that we need to do, right? Because here we go ahead to create those tables. So we can run this SQL query and fingers crossed it works. So we now have, if you look at the public schema, we now have those three tables. So we have customers, products, and then sales, our sales table, right? And I think probably if we are to try some kind of a SQL query, so let's try another one. Let's say select star from public dot, let's say customers. Let's try something like that. Right, we should now see the customers information, right? So this is just our demo data. So we have added our SQL database and then user, so we can go ahead to now run the runtime, right? So let us go to IAC slash runtime. Oh no, CD IAC, CD runtime, the VS Code, connector to the um, whatever it's doing to allow you to kind of view the commands. It's just sometimes a bit too buggy. I might need to remove it. Um, Let me save this so I don't forget. Yep. And then, so we will look at, so we have done with the foundation, right? We've looked at a couple of the modules. So if you look at the runtime, let's do a Terraform in it, right? Similarly, you need to pass in some variables. So these variables, so that is after you have gone ahead to deploy your your foundation and you have gone ahead to deploy the images, you need to go ahead to update these, right? So I think I include that in the README, but you need to go ahead to update the front-end container image, AI agent container image, and then MCP Toolbox container image, and also your project ID, right? Because these need to reflect your containers, right? So that the foundation can use it. So we would then go Terraform apply in the foundation, sorry, in the runtime, right? Now, in the runtime, we do something neat here because Terraform also allows you to be able to access the state, right, across like different backends, right? So maybe if in our case like this, we need it because we need to be able to know what is the service account ID, what is the service account email, what is the Cloud SQL instance name. So in our foundation, we output some of this information inside output. So the secret name, the project, the artifact registry URL, the private IP of the Cloud SQL, we put all of these things into our outputs in the foundation so that we can then use this data resource right here or this data source to then access. Oh my goodness, this thing, I really don't know what happens. It's the get extension. You just press on something, it just displays some visual. Let's go back runtime. Yeah. So yeah, it just displays, you know, it just allows you to then connect to that remote backend, right? And then you are able to get that state. Now, I didn't mention this, but in our Terraform configurations, I make sure that we are using a remote state. So we are using Google Cloud Storage buckets. We are using some storage bucket, and then we are putting some path prefix. So for the foundation, we do slash foundation, and then for the runtime, it also has also its own connection, but then we do a different prefix, right? This is to help us so that, because this is how we do things in production. In production, you don't want the state to be local, right? Unless you are using maybe something like Terraform Cloud, then you can also use your Terraform Cloud remote state or backend. So with this, it allows us to then connect to the foundation and access those outputs from the foundation and then use it inside the runtime. So this is very good to allow you to kind of orchestrate separate environments. So I'll go ahead to say yes. I will also switch terminal and leave it to run. And then we will look at it. So we have, mostly it's cloud and services. So we have the front end service, we have the service name, and then we have a container that we pass into it. So it will depend upon the AI agent service, right? Because it needs the AI agent URL, right? So it will wait for the AI agent service to be deployed before the front end will be deployed, right? So normally, I think probably the MCP toolbox will be deployed first because the AI agent also needs the MCP toolbox URL. So the MCP toolbox service will be deployed first, followed by this one. So as you can see here, we specify some ports, we specify some CPU and memory limits, right? Some scaling for the maximum and the minimum. We want to make sure that traffic is always 100%. The ingress should be, so all of the traffic should be there by default. Um, sorry, all of the ingress, right? we are we are allowing ingress from all. So that means from anywhere at all. So from the public internet can send traffic into the front end service. And then we are using this to basically allow unauthenticated access. So this is what you use in your Cloud Runs version 2 service if you wanted to allow unauthenticated access. And then we are using direct VPC egress with VPC access. And then we are connecting it to, so in the same, we are also accessing the remote state and we are accessing the VPC subnet ID. So we are connecting our VPC egress and then we are connecting it to the VPC subnet ID, right? Same way, you might need to enable delete protection, right? This is something I need to probably note in the README, right? But maybe for your Cloud Run services, unlike maybe Cloud SQL, you might be okay just even accidentally deleting because you can easily bring it up. But probably if it's in production and you have some load balancer, you might not necessarily want that. So you can enable in production, right? Just enable in production to make sure that. Oh my goodness, this visual display, I don't know how to cancel it once I come into it. I really don't know how to let me see. Is it escape? Okay. Okay. And then we have the image, right? Then we have this environment variable. Okay, I think we've already mentioned that. So that's the front end service, right? The same way we have the AI agent service. And so that one also, we have a name, and then we have some further environment variables that we provide, right? And then we provide also the different model names, right, as environment variables. And then we also provide the toolbox URL. So this will also wait for the toolbox to build. And then we provide the Google API key as an environment variable, but it is going to reference the secret, right? And then we specify some CPU because we wanted more CPU and memory because that is going to do AI processing, but that is fine. And then for that one, the ingress, we want only internal. So that means anyone that needs to connect to this service needs to be internal. So in some ways, we protect our service, right? So that is why I have not necessarily focused on when it comes to the MCP toolbox, I've not really focused on the allowed origins because traffic one needs to be internal and two, we require IAM authentication. So that means the service account needs to have the invoker role on that service before it can be able to access it, right? So you can see here that the AI agent service, we pass in some invoker members. So this is it. So if you look at the Cloud Run service module, the Cloud Run module, right? If we pass in any invoker members, let's come down. If we pass in any invoker members, we basically grant those invoker members invoker role, right? The run invoker role on that particular service, right? So by doing this, we kind of restrict the access to one IAM authentication and then internal only, right? But of course, still you should add that allowed origins just to be sure. So maybe a rogue container does not access your MCP toolbox, right? Yeah. And then we access the network interface. So we have our VPC with a subnet ID. We also do the same thing. We connect it to this is only needed because it is only the MCP toolbox that needs to connect to Cloud SQL. The reason we are also connecting the other services to the VPC egress or to the subnet is because we are also using the ingress to be internal only. If the ingress was all traffic, then we don't need the VPC egress right here, the VPC access. Because if the ingress is all traffic, then that means that the other services can be able to reach it. The only thing that probably they need to provide IAM authentication, right? But since we are saying that, okay, for all services, we want to accept the front end, we want to make the ingress internal, then that means that if the front end wants to connect to the AI agent, it needs to do it through the internal network, right? Unless we also make the AI agent allow traffic like ingress to be all, right? The ingress traffic should be all. But since we have made it internal, then we need to also connect the front end like this to the VPC so that it can send any request through the internal network, right? So it will do the internal network, or use the internal network to do that connection. But if that was not the case, then we can just go ahead to remove the VPC egress and only keep it on the MCP toolbox, because that is what needs to connect to Cloud SQL. But this is just a special case I wanted to experiment with to kind of keep the traffic purely internal. So it's only the front end that you can ingress to it from the internet. But then for all of the other services, the traffic is internal only. So that means that they need to connect to it through the same VPC, and then they can be able to connect to that service. So we have this there. Same thing with the MCP toolbox. We are providing the arguments, and then we are providing some of the DB environment variables, right? The host, the DB name, and then the user. Remember, we need to remove this from the service account, right? So we remove that from the service account, and then we provide a volume mount, right? Because we have the secrets. So we have the tools.yaml. Remember, we put the tools.yaml into the secret. So we have to now provide it back, right, as a volume mount. So as you can see here, we have a volume mount, and then we have the volume declared here, which then points to the secret, right? And that is it basically. That is what we have inside our runtime, right? I don't know, what change did I make? Did I make any change? Let's see, what change did I make here? Okay, yeah, that is fine. Okay, so now fingers crossed, this worked. Okay, yeah. So our front end also worked. Good. So our runtime has been deployed. We can now go to Cloud Run and let us refresh. And we should see the three services. So you can see that the ingress is internal, but then for the front end is all, and only the front end allows public access. Right. So we can click on it, and then we can go ahead to open it. And again, fingers crossed, we don't experience any issue and everything works all right. So we are going to ask our first question. So who is the customer that gives us the biggest revenue? Right, fingers crossed this works, and we don't have to spend time debugging issues. Let's see. Okay, good. So it worked, right? And so the front end make the request to the AI agent. The AI agent talked to the MCP server, right? As you can see here, the MCP server talked to the database, and then we got back the response, right? And we can ask a question that generates charts. So let's say, what is our revenue per month? What is our revenue per month? What is our revenue per month in the year 2024? Right, to see if we can get some charts and then we can be able to review it. Um, yep. So I think these are default things about, how do you call it? This that you can get. I just haven't checked it out, but so you can see we do get our chart, right? You can even specify only specific months. So maybe per month, let's say from maybe June to December, right? If we wanted maybe only June to December, then we can do that. So we have this chart right here. We have a chart summary, and we are able to display the results, right? We're able to display the results. So same way, we now get June to December and we get this result, right? So we can see our application working from the front end to the back end. We deployed our infrastructure with Terraform, and we are able to, kind of see a working application. Now, one interesting thing I want us to look at is use CloudTrace. So we have basically set this up to work with CloudTrace. Now, when you come to MCP, it allows you to provide, I think it supports telemetry in some ways. I'm not able to find it, but the MCP toolbox also supports telemetry, right? So you should, yeah, Cloud Trace, yeah, it supports telemetry as controlled by the environment variable, right? if you can remember earlier on, as controlled by the environment variable here, right? Enable cloud trace, which we set to true here, which we set to true. If we look at the AI agent, in the environment variable here, we set enable cloud trace to true, right? So Google Cloud would then, kind of enable cloud trace for the various LLM operations. And then also the MCP toolbox also supports some level of telemetry, right? Using open telemetry, of course. And if you are on GCP, you just need to specify, because it has a Google Cloud exporter, and you just need to specify the telemetry-GCP, right? This is also partly why in my AM section, you see that my service accounts have Cloud Trace agent, logs writer, and the monitoring metric writer to make sure that they can be able to kind of write, and then act as the Cloud Trace agent, right? So localhost here, I've closed that one. So now we are inside Cloud Trace. So inside Cloud Trace, let us just go to, I want to see something. I want to just look at the last 1 hour. Let's just look at the last 1 hour. Yeah. So you can see a bunch of traces right here, right? So let's just look at one of them. So if we look at the run, right? So this is the API endpoint where we send the request to. So this is just Cloud Run, and then it's just showing the latency. So by default, Cloud Run also allows some default automatic tracing, but then it's just going to show you the latency across the request. It doesn't show you each operation happening and what happened with that particular operation, right? So you can see the graph also right around here. You can see some of the traces, right? You can see some of the various spans, right? So the span is kind of represent an individual operation that was performed, right? So the automatic one by Cloud Run is to just record the latency across the request, right? But once you integrate telemetry into the application, you can collect a bit more further for each individual operation that is happening. And MCP Toolbox and ADK kind of allow us to easily do this, right? So if we look at something like the call LLM span, right? So we have some call LLM spans. So you can see them here, where at certain point LLM was called. If we just look at them, they will kind of help us to track from where did the request start, and then we had that call LLM span. So you can see that there was this trace which is responsible for this particular one. It lasted for 13 seconds, and the invocation lasted for 13 seconds, and then it invoked the agent, corporate agent, right, which is like the root agent right here. So the root agent we have here, right, was executed, right? And that then took, the root agent we have here, that then took 13 seconds. But it called the retriever agent, which took 8 seconds, right? And you can see that it had an LLM call, which took 4 seconds. You can even see here that the the MCP toolbox is not even a bottleneck, right? Because as you can see here, its call is even like 43 milliseconds. So most of the operations are the operations that are taking time is around LLM calls. So you can see here the retriever agent called the LLM, which then took like 4 seconds. And then it executed the two, which took like 43 milliseconds because after it executes the two, it also needs to kind of like process the response. So it execute or it called the LLM again, right? And then finally, once it was done, it forwarded that to the presenter agent. Then the presenter agent called an LLM, which then took 5 seconds. And now the operation was completed. So this allows you to kind of go through the various processes that was happening inside your application. So you can be able to visualize, okay, so this was executed. What happened? What was the request? So you can see the results that even came out. Right. So the agent to response, you can see that here, right? And you can see the AI to description. You can see that here, the AI to name. So this is very good actually. As I was looking at it, it's very good from Google ADK because it allows you to kind of like go through the whole process and then identify, all of the actions that happened. You can be able to see what tools were called. Maybe it's there a tool that was called that shouldn't have been called. Even though you can use the agent ADK evaluation to perform some of these things to help you. Um, You can also use Cloud Trace to go a bit more further to identify, all of these points, maybe some tools that were called that should not be called, some tools that were taking more time to execute than usual to find those out and then fish them out. Right. So you can see here too, the LLM here was called, and you can see some information about that. So if you look at the LLM call, you can see this is the config with some information about the system instruction and stuff. We called some generate response function. We got some, session. We have some mass token. So all of these things are here for you to just be able to view, right? So this is a very good way for you to kind of find out what is happening inside your application and the various steps that are kind of going on. So you can see there are some spans that you can look at if you wanted. So there are some spans here for invoking the agent retriever agent. So you can look at that span, which I think one of them we just looked at. And then you also have some for the toolbox itself, right? So the toolbox also provides its own telemetry, as you can see from here, right? That there is some level of telemetry that it provides, right? And you can see that the toolbox was initialized, right? So it took roughly 433 seconds, right? So this was run, and then this took, roughly some microseconds. So a lot of operations happened, and then finally that was completed, right? So it connected to the source, right? Let's see what is happening here. So you can see here the container. So there's the Postgres source, right? And then the language is Go. And you can see, let us see here. Let us try the toolbox connect to see some information. I think it's still the same information. Okay, so yeah, no, the various toolbox connect kind of load the various tools. So you can see this one loaded the get sales API. This one loaded this tool. This one also loaded this different tool. They are all pointing to this kind. So it allows you to kind of like go through. So probably if some or one of the tools fail, you should be able to come here and then find out what tool failed, right? And so list tables was also loaded, and then maybe be able to debug what happened, right? And so the two sets, you have the two sets also being loaded here. So you have two sets in it, and then the two sets being loaded, and then finally the prompt sets, being loaded right here. So this is also a way for you to kind of like go through the toolbox and what is happening, right? So this, I hope this whole project kind of gives you a more high level overview of, from infrastructure to some of the resources being that you have to deploy them manually to having to deploy the other resources that depend upon some foundational resources to visualizing the application and then being able to also use Cloud Trace to kind of go through the processes of what is happening in the application and then finding out various pain points, the errors and stuff like that that are happening, right? So yeah, I hope that is useful. And let's see. So what I'm just going to do is I'm going to go ahead to update the README with the section that I mentioned, which is here, right? And then I'm going to also go ahead to destroy the resources, and I will make sure that in my foundation I remove the duplicate API for the Cloud Trace, right? That is all. Thank you for joining, and catch you next time. I'll be looking into other Google Cloud services and how best we can use it, but we will still be working around Cloud Run because I just think it is just good for most things that you want to build, whether you are prototyping or you want to just get quickly started with something. It's just very good for it. Thank you for joining.